Well, hi guys, Emma again. Welcome back to the spare room. A few little jobs. This is part 14. I think it's going to be the last part of this little dynamo build. First job's to make a pulley, and that's a pretty quick job. Is put a shoulder on him for a step, for a set screw. Drill him and run a reamer through it with a little bit of oil. So there we go. Next job's part him off and drill him, and probably break some of those sharp edges. And we've got a little pulley. Run through with a 2.5mm drill, an M3 tap. And that's a very quick and easy little job. So that's the first bit done today. Next thing's on this end, we need a couple of little 4mm thumb nuts here. A bit of contour on them and a knurl on them. I'll find a bit of brass and we'll make them up next. So we're going to put a knurl on these. I'm using the indexing pick that I made, which has got a taper that goes in a bush and a hardened point, and that's just spring steel. It's really not very easy to get a good shot of this. But this goes in here. Anyone looking at Lorch lathes, that's a Lowenhurst thread in there. There's an obsolete German thread standard that no one knows much about, but if you're looking to replace that bolt there in a Lorch lathe, that's what that is. Anyway, I reckon about 24 divisions would be good. We put that back in there. And I'm just going to do them both at once. Probably reasonably deep, I think. Just got about a 50 degree thread cutting tool, 45-50 degree, like a straight tool, and that's just on its side there, on centre height. So we've got a straight knurl on there. It's probably a little bit coarse, but it'll do the job and look nice. Next job's to run a tap through there. So that's a couple of thumb screws for there. They'll do the job, just to hold wires. One there and one there. And after listening to comments on here and the comments on my Instagram and Facebook, I've decided to go with these. Probably if I did them again they would be a lot nicer. It's the first time I've really ever etched brass sheet like that, and I think they've come up alright, and they kind of look old fashioned and cool. I was going to spray paint the backs and polish them off. I really don't know if they need it. They kind of look nice like they are. This one's been carefully bent. It's probably the only way to describe it. What I did was annealed it and then clamped it on the old magnet, or the first magnet we made as a former, and bent it round, so that fits there nicely. I've got some 8BA brass cheesehead screws, the same as these. I'm just going to put one in here and one in here. There was a comment about these screws looking ugly, and they do. It really wants 3mm brass cheesehead screws or roundhead screws, and I might see if I can get some of them this week. This grey was originally intended to be an undercoat, and I've got some black there that I sort of was going to spray over the top of gloss black. I'm not sure now. I might give this a bit of a sand up and another coat of grey, and we'll call that gun, because I quite like the way the grey looks. So next job, I guess, is to centre punch these and drill them, and then spot the magnet and drill that too. We're going to wreck this paint, so I'm going to have to touch that up again anyway, so let's put those two screws in. The answer to how do you tap this is very carefully, actually, and with a fairly high heart rate. So we have these cheesehead screws, and I think they're going to look nicer in there, and I'm going to chop them off and run a thread on them so they're nice and neat, and change them over. That'll be the next job. So that's them done, and the other job is just to mount this commutator on the shaft properly. not a real good mechanical fit the way it was. And now we've timed it and messed around, what we've done is used Loctite super glue and a plastic activator, and just put some activator on the shaft and a little drop of super glue, and everything's locked solid now, and it's not coming off. It looks good. So that's another job done. I've put all this back together and adjusted it up, and sit down and wait for a day for the paint to dry. So it's Friday night, which is 3 or 4 days later. Everything's assembled back together. If we want to have a bit of a look, it's looking pretty nice. I put decent paint on here. All the plates are on. I haven't yet replaced these screws, and maybe at some point I will either find some or get excited and make some little brass screws to go on here. They don't want to be any smaller than that because there is a bit of load behind them really. They hold the magnets in nice and tight, and I'd rather over engineer that a little bit, but probably I'll make some brass screws. I've just hooked up some wires, and I've got a lantern battery which is 6 volt and is pushing out about 8 amps when it's brand new. Now, if we put the multimeter in series here and take a measurement when the motor's running, it's drawing about 3.3 or 4 amps depending on how it feels. I've done a little bit of work on the brush friction and stuff, and I've got it down to about 3.3 amps, which is a fair bit. So this little battery at 7.5 amp hours or whatever it is, it's not going to last a whole lot of time, but it all runs nice. On this battery there's not a lot of light, not a lot of real power. I don't have a 9 volt supply, and that might change, but I think that's about optimum. There's a lot of power on 12 volts, but we get that strong retro electrics car smell, ozone coming off. There's none at all here with this, and nothing gets warm, and it runs beautifully at 6 volts, but at 9 volts seems to be about optimum, and we will try it at some point on a purpose-made 9 volt supply. But that's running nice, and it'll run there on that battery I reckon for probably half an hour, a bit longer. So I'm sort of pretty pleased about that. I wanted to sort of say on this video the things that I've learnt. And I've learned a lot about electrics. I've learnt that if we're going to make a dynamo that actually generates a reasonable amount of electricity, we're going to have to put a bit more design into that to start with. And I've learnt that mathematics are a great thing for model engineering, especially this sort of thing. I've learnt that this will probably be the last project I ever make with metric screws in it, because you just can't get the range, and they all look a bit modern and a bit awful, and I like old-fashioned screws. So it's going to be BA and UNF probably from now on in. What else have I learnt? I've learnt there's some amazing people out there in YouTube land, and there's always been useful and well thought out advice. I don't think I've learned enough about magnetism yet. It's a bit of a black science, and there's still a lot to learn. And I've learnt that if I built this again, I would build it a little bit differently. I put a fair bit of time and a fair bit of energy into producing something that's well made and probably over engineered, but the 2-pole rotor sounded like a good idea when we started. It's probably just a bit of a pain really to make anything that actually works, because you've got to start it. It's not self-starting in any way, shape or form, so that's a bit of a nuisance. If you stop it there, it will sometimes self-start, but not always. Now that's doing a fairly reasonable speed. I'm going to guess that at about 1000 RPM, something like that. Like I said, it's got very little load. If we run this as a dynamo, and I have done that, the voltage driven, or the voltage given off at 4500 RPM is minimal, to say the least. It's less than a volt, so there are things that we could build into the design to improve that quite a lot, and I've learnt that through the process of building it. But anyway, I'd like to say thanks for watching, everyone, and thanks to all my new subscribers for being so nice and generous with their time and watching these videos. And to all my friends on Instagram who've been enthusiastic and have kept me going through some of the times that didn't run so smoothly with it. And I'd like to say thanks too to the guys in the machining YouTube community. I don't know if everyone's a member or has seen the machining YouTube Facebook group. Fantastic bunch of guys. Everyone that you watch on YouTube's there. That's Prince. Where to go to now? I've been thinking about this, and probably I could build a steam engine and run a little light bulb off it. It's pretty boring really. It's not, everyone's got one, and to build a little engine that, this really isn't a model. It's I guess it's more a laboratory tool than full-size replica of that than an actual model or a toy. So building a steam engine we've just had a visitor there. Have a look. Here he goes. Now, building a steam engine that's going to actually look good with this and drive it limits us a bit. And there are a couple of models out there that look really good on here, but I'm not really up for another steam engine project. I've got too many to build already, so we're going to give that a miss. The other thing is to make something for this to drive as a motor, and that seems to be the sensible thing. And at 9 volts it's got a fairly torquey power output, and it's capable of doing some work. And probably what's going to happen at some point in the future is that I'm going to make a cast iron or a cast aluminium stand for it with 3 nice ornate legs, and put a brass fan on it with a nice surrounding wire, and make some sort of a worm drive or a bevel gear drive mechanism to revolve it backwards and forwards and make a nice antique desk fan. That's sort of where we're headed with this, I think. So let me know what you think in the comments. I'll say again, thanks for watching, and thanks for subscribing and for pressing the like button. It's all much appreciated. And we'll have a look at another project next week. So thanks guys.